Alright, welcome to this Ring Rider game development stream. Here's the game I've been working on, a nice little phone-based ring riding game where the player controls this little ball and goes inside rings and tries to collect as many coins as they can, jumping from ring to ring, avoiding this little central circle that grows and these little enemies that cycle within and without the rings. And today what I wanted to work on in the time available was a bit of a save and load system. Very simply, I have two scenes in the game. There's the menu that the player gets to see when they first join the game, open up the game, or when they go back from the actual level, which is the second scene at the moment in the game, which we were just seeing. Now, what I want to do in particular is to make sure that the game can track certain key pieces of information. Most importantly, how many coins the player has collected and possibly used, as well as a high score, maybe the amount of gameplays that they've done, and importantly, the character that they have active. My vision is that the game will allow players to buy different characters and then unlock them and then switch between them. What I'm going to try and do now only is to have in the menu an option for the player to switch the character just by pressing that button, and that will then change the color of the player running around in the menu screen. Now, if that choice is made in the menu, I want it to also, of course, persist in the level. So when the player moves from the menu to the level to actually play the game, having chosen one character, well, the level should know that that's the character in play, and it should know how many coins the player might have collected overall, and so on. So, what can we do? It's not a lot of information we're tracking, so in theory we could use the inbuilt player prefs feature to just log a few pieces of string or numerical information. But I wanted to do this a little bit more properly, so I've been building a saving and loading system that takes a defined save class and serializes it into a binary stream, which can then be saved into a file on whatever local folder is relevant, whether that's on the PC or on Android. That's what the save controller does. It has a method for taking a save file that's passed to it and serializing it and saving it to file, and then a load method that picks up a serialized file from the hard drive, does the standard thing, parses the binary stream, and then returns a class populated by the values from that save file. What that means is, in this session, we can look at changing the character from pressing the button in the menu, saving that information through the save controller into a save file and making sure it loads properly in the level. And then additionally, making sure that once you do change the character in the menu, the color of the player character going around in a central circle changes appropriately. And then, of course, that when you're playing the level, the color of the character there matches the character that you've selected. So that's the beginning at least of a nice character saving system. And where have I gotten to so far, and what do we want to do? We can take a quick look at the save controller just to substantiate what we were saying there. We have this save game method. This is a singleton class, so only one should exist in any given scene. And we can see that we have the method here being called in two places already, so both in the menu and the play scene. Creates a new save, takes the things passed in from the save, I suppose more for explicitness' sake than anything else, although here you could do something more elaborate. And creates a new binary formatter just from the IO library namespace, and creates a file into whatever the persistent data path for that given environment is. So this will be one path for Android, be a different path for PC. Eventually, it might be different for Linux or iOS. And then just creates a file or overwrites it if it needs be, assuming there's only going to be one save file per application at this point. Does the serialization in that file that's been created, and then closes the file so that it can be accessed later on by another method, and there won't be a conflict of access. And conversely, here we have the load game method, where okay, at the first it just sort of says at the moment it's that the game is loading and lists where that application persistent data path is. Had it for a bit of debugging. And first, the load game checks if there is a game save. So if you first start the game and it's your first time running it, it will try to load the game, and this just catches the case where it doesn't exist yet. But as soon as you've done something or played the game once, it will create a game save. And this is already familiar now. We're again instantiating a binary formatter from that same system.io namespace, creating a file, this time using file open instead of file create, making sure that we're pointing to the same location, so application.persistentDataPath / gamesave.save, just within an opening file mode. Then we deserialize that file as a save, so having this syntax where we have the save in brackets before the method we're calling, make sure that it gets cast into that format. And finally, we close the file. And here it does another mapping of this loaded file explicitly, property by property, which is possibly a bit overkill. Lets the developer know that the game has been loaded and then returns the loaded file to wherever this method has been called from. So straightforward enough if you've cheated and you know what serialization is. Though I do notice that you have to be careful and mindful about what kind of data types you try and serialize, what Unity allows you to serialize out of the box, and what's not. Great. So let's see what needs to happen next. We could also take a look at the save class. So we have a serializable class, so this can be streamed because it has been marked as serializable, and it has basic data types only. So it has the amount of gameplays at the moment, the amount of coins, a high score, a number that denotes the active character, and then a list of unlocked characters. So I'm figuring I can track this as a list, so a dynamic kind of array type, where I can add and remove items at will, because if we imagine a game with 10 characters and you can cycle through them and they each have a cost and you unlock some but not all of them, there's nothing forcing you to unlock one at a time. To say that I've unlocked characters 1 to 3, you can also unlock characters 1, 3, 5, 9, whatever. So therefore the tracking should be a list of these integers that then gets checked when the eventual character selection screen is fully fleshed out, or more fully fleshed out. And we can also take a look at the logic of where this gets called and not. So we see that if a level is ending, so we're now in the game controller class, and there's an IEnumerator, so a coroutine that takes some time to run, that in one branch will play an ad if that's relevant, and then whether or not it plays an ad, after that it will create a save, store the current values that this class keeps store of the properties we're interested in, and then saves that. Now I notice that it doesn't have the unlocked characters. Used to have it as a character list, so a specific class, but actually I want it as a list of integers as we just saw. So let me add that. We will have it here as well, so that even though in the level it should never change, might as well have it available there. Maybe there'll be a quick button for that or something. At least it stays explicit and kind of easily comprehensible. And right now, at the moment, once the save has been completed, the resetting of the level itself happens through just a whole reload of the scene. We could do this differently. We could just delete the existing level, move the player back into the initial position, whatever, and then rebuild the level and go from there. And maybe we'll end up there. Right now it's taking the easy, lazy option and loading the scene again. Okay, but that's neither here nor there. I think we need to get some typing going. So this is saving the game. Let's take a look at the menu. We've been in the play scene. We want to get to the menu scene. Let's take a look at that. Does it still run happily? Always good to check. Here we go. So we have the menu. This button allows us to play. This is what will eventually open the game character selection screen, but right now I just want the player to be able to tap this, and that will then change the character and update the color and possibly swap the color. Doesn't need to do that. Just updates the color of the circle going in this main thing, indicating that that's the character you'll be playing as. So let's see how we would do that. Think about this. We have a script controlling all things in the menu, basically called menu controller, predictably enough, and it's a mess. However, we do already have a change character method here, one we haven't tried yet. So now we know that we have the kind of unlocked characters integer list, right? We just mentioned that. And that's in the active save. So what we could do is look at the active save. That's going to be loaded very early on. Should we load the array right away? Let's see if that's smart. List integer unlocked characters is a new list integer class, and once it's loaded the game, I'm going to try that. I'm going to say unlocked characters is the one that's in the active save. Great. So we're now in the loading of the game initially. As it loads the game, it's doing some things that we might get rid of. And what we basically wanted to do is understand what are the possible choices you can have. Now we kind of want in this stage to hack it a bit, because we know that all of them should be allowed. So let's instead change the approach a bit and just initialize this array as something quantified. So known, we know all 4 characters. Okay, so now we create that as 0, 1, 2, 3, and I forget the syntax of initializing a list. And what we want to do is initialize a list with values already. And we don't put the initial values inside the brackets, we put them in curly braces after the braces. So this means that I will start this whole level with a list, and it just goes from 0 to 3. So there's 4 characters. And the active character is 0 to begin with. However, when it loads the game, here, once it's done that, it's going to, it calls it there, it's going to say that the active character is whatever the active save active character is. Right, so we'll all this work now that we're trying to load the game for the first time when there's nothing there? I suppose the way to do that might be to make sure that the active character defaults to 0. That's one approach we can take. Alright, so back to the menu controller. We're saying that the active character is there. So now we have the active character, and then we are mapping this button that changes the character. Okay, so the simplest thing to do is to cycle along that list of unlocked characters and then pick that next available one in your as your active one. So we have a list, and we will increment that list. Do we know where we are in the list? We can find that out. So int index is the unlocked characters index of the integer of active character. Right? That's the current index. Current index in the list of unlocked characters right there. And then here we can say increment that by 1, and if it goes over and around the bounds, then we loop it back. So index plus plus if index is greater than the unlocked character, the amount of things we've unlocked so far, then what happens is that the index reverts to 0 instead. Okay, so we might get the index of, let's say we've got active character 1, so the second one in the list, and we've got all of the 4 active. We increment it once, we end up with index 2, and also character 2, and then we have index 3, character 3, and finally we increment again, and we go index 4, and it checks there are only 4 elements. So we need to start if we have index 4 going beyond, so if we have 4 is greater than 3, then we go back to the 0th element of our list. And then we say active character is whatever unlocked characters index says it is. And I suppose this is nice because we could swap around the IDs. We could create our 10 characters and then for whatever reason assign them IDs from 1 to 10, but then decide to reorder them later or randomize them for different players or so on. So we're not tying the players so strictly if we use it this way. Great, so now we've set the active character, and we should also, it saves the game here just to keep track, and we could find a smarter place for this. It saves the game next. Saves the game next to be able to record this change, which is the next step. So we would say active save active character is now the active character that we've just said, and then we've updated the class of the save file, and we can now save the game just so that the change doesn't get lost, because you might press this button and then quit, I suppose, and we'd still want the player to have change to have persisted. But what we haven't done yet is actually update the art of the character. Now, how do we want to do this? What I was toying with was having an array of what the character IDs actually mean. So let me explain. We're now just passing back and forth the number that defines the character somehow. It gives we know that we're in character 1, character 2. But what does that actually mean? So we can approach that in a number of ways, but basically somewhere we should store more well-defined list of what a character is and what character 1 is compared to character 0 or character 2. So how have I been doing this? I went ahead and created a scriptable object for characters. In Unity, scriptable objects are basically the best solution to to have something where you know you've got a number of properties and you want to define multiple ones of them, and this allows you to define them here in the editor and kind of drag them on to prefabs, to other objects, and then maybe start from there instead of. Uh, it's a great way to store things like character information. Maybe you would have different weapons or different level properties and things like this. So we have a script that defines the game character, scriptable object, has an ID, the name, the cost, the prefab if we wanted different color, different objects, meaning what do I mean by this? I envision a future where it's not the case that every single character will just be a round sprite, but instead they might have their own sprites. So we could store a sprite, or maybe we'll have different prefab objects, all told. But we certainly want to store the color because we want to change that color. So this list isn't being saved in a save game. We're just storing the ID, and then we are creating a list, master list that can be drawn from to then actually do stuff with these characters, both in the menu and the level. Okay, so defined, use the game character scriptable object. Then you can create from this menu that pops up a scriptable object, and here we can define them. So here we have character 1, the purple one, the 0th one. Moment, I'm only interested in the ID and the color. Let's make sure the next character is incremented as ID. Next one again, and the next one again. So now we have these 4 character objects, scriptable objects that have been defined with the color and the ID. Remembering that the key thing we want to change at this point is the color of the player character. And that's already what I accomplished. But what we want to do as well is to have the characters stored somewhere, so we know what that means. I'm thinking maybe we have it in the save controller because that's going to be the same between them, whereas the menu controller and game controller are different between the two scenes. So we add the character controller script, and I will review this script that I wrote, was it yesterday? Basically, I have a list of character prefabs. I'll keep it private instead, and we have a list of character scriptable objects, I think. And let's see, so can we now populate that with what I think we would want to, which is, let's say that we have 4 scriptable objects. And we just drag them into position. That won't work because of a reason I realized and then forgot. Game character scriptable object. Okay, because I'm not calling it the right thing. That will, of course, explain it. We must be calling the right object name here. Let's try again now that we've recompiled. Great. So we're now building this mapping. We've actually fleshed out our 4 characters already. And now we know that the 0th element of this array, this list, corresponds to the definition of character. So now we can use this structured information to say, okay, if you have selected character 0, you will get character 1, and so on. And you could imagine that a player, whilst this list will contain all the characters we define, the player may have only unlocked 2, and then it will choose between the 2 available elements. And from that game character scriptable object, we can then pull out the color and use that to populate or render the thing. So render the game character again. So let's maybe have the character controller allow that kind of recoloring. So we can create a public method of update character, for example. And we call it a void. All it's going to do is update the color of the active player object. So we pass it the index of the game character scriptable object list we want. So basically the index of the index in the list. We pass it the number ID. And then we say that the color, new color, basically is whatever we find in the character scriptable objects ID dot color. Okay, so what's this doing is saying that this method will be passed that number that we've gotten to. So in the menu controller, we've pressed the button, we are changing the character, our index moves up one, and then we pass whatever number ID in the unlocked characters we have by calling get component. So this is making the assumption that we need to find the game controller. So save controller instance. Public. Doesn't say it was character controller, pardon me. So we find the character controller instance. Update. But if we're doing that, we should also make sure that this is a singleton. So now that it's a singleton, we should be able to access the instance of that and know that there's only going to be one. And there we can call the method we just call the method we were just working on, the update character one, and then pass the number that is the active character ID. So in our character class, we defined in our game character scriptable object, at least we defined an ID. Nice. Okay, hitting the half-hour mark. Time flies. Still having a... Oh, yes, character controller does have the same name as a built-in unique object, so let's be good people and rename it game character controller in this case. And that means that we should also rename it here directly in our script. Great. And if that's being referred to anywhere, we may need to know. Yes, it is. So game character controller has the name, same name. Changed it here. Game character controller. So here we should find game character controller instead. Still seemingly charging it from somewhere. Let's see if we try and play. Give us the complaint. No, doesn't give us the complaint anymore. Okay, so let's get back. We're changing character. It should try and find the game character. Let's make sure we get there. Updating character color. At this point, by going to the update character, passing it that, we are here in the game character controller. Let's reopen that. We see that it says character controller here. But didn't we just update it to game character controller? Wonderful. And we did not get that covered here. Okay. It's now giving it a saying we have two of these. Let's see. Let's reopen game character controller. Saying there's ambiguity, but I'm only seeing this being defined once. I'm a bit confused from that. Let's be more consistent with our naming at least. Great, okay. So now we're getting the new color, but we haven't done anything with that yet. We need to find the player character itself and update the color somehow. So where's the play character? It's inside the play button's inner track as in the menu rider. So we see here, but we see also that this is not a plain circle, which we would want, but a pre-colored circle. So let's see if we do change it to that and then change the color. Okay, so we want it to be nicely programmatically changeable. So we change the sprite, the basic sprite of the menu rider game object to be white, and we can change the color in the sprite renderer component through our code programmatically. It's giving me some errors here around the global namespace already containing a... Okay, fine. Maybe we're just using the reserved words and things we shouldn't be doing. So let me rename this to player character scriptable object. That probably explains why we're seeing some errors around ambiguity earlier. Now it's going to give an error here because we don't anymore have game character as a thing. Great. We've got a bit of nomenclature ambiguity between game character and player character. This is how things get messy. However, at least we're not getting any errors, and if we try and build, now we should not get this namespace conflict either. Let's give this a try. How lovely. Now you can see that we are having a white uncolored sprite, which we should nonetheless default to purple, I think, so that it always loads nicely. How to do that? Let's pick the purple color to match whatever we've got here, that hexadecimal code, and make sure that whilst the sprite itself is now white, it does get colored by this hexadecimal code to begin with, and then it gets updated whenever we load the game. And that is where we would want, whenever we load the game, to also do that. Good thing to note. So, where were we? We were finding the game character. So we could do it this way, brute way. So we track the transform player character. This is just a sprite. Maybe we'll want to change it more later. So keep the player character. So we set in the editor for each scene, we set the player character, and then we assume that it has the sprite renderer. So we say player character get component sprite renderer. And then in that we say the color gets set to the new color. Lovely. So that could already do it. What we need to do is populate this player character, so drag that into the right spot. So we had this script we were just looking at here in the save controller was not it, the game character controller was it, but it's called the player character controller. So did I end up duplicating stuff? So now we have this slot here to say which transform is it. It is the menu rider. Great, so now we've done that. However, even though the logic works, we're not yet calling the change character method from anywhere. So let's make that happen. But thankfully, that's pretty easy. So we've got this character button here. What we want to do is very much just adjust the button functionality here. So it's a ring script character button. It's the canvas character button, right? The GUI character button. So we have this inbuilt Unity button script that allows us to define what happens when clicking or tapping, touching this button. The moment it's been set to start level, so it's already got the menu controller as the script it's going to be looking at, and remembering that whatever we're calling has to be public so that it can be accessed from our own, I believe. We just say that instead of starting the level, we change the character. Let's see what that does. So we're going to play. We've now changed what this button does, and it says the index is out of range. So maybe the index wasn't initialized first of all. Index of active character. Because we haven't loaded